Hi class, we're going to talk about the Pythagorean Theorem. That is just a big name to explain how we figure out the area of triangles. And it is just a big name for our formula to figure out the area of triangles. So basically what it means is that we would do a squared plus b squared equals c squared. And that would give us, this is the formula to figure out the area of a triangle. So this works for all right triangles. Let me erase this real quick. And there are certain things that we need to know about this formula or the Pythagorean theorem. Okay, so when we're dealing with the a squared, I guess I'll write this back here. B squared equals c squared. You can look at this triangle and say, okay, but how do I know? Let's mark this side 10. Let's mark this side 12, and let's mark this side as a 15. Okay, so you're asking yourself, well, how do I know what is A, what is B, and what is C? Because if if it equals C squared, how do I know which one is the C? So how we figure this out is by knowing what sides are A, B, and C. So when we look at this triangle, how we're going to look at it is we're really going to use the right triangle to determine what is what on this triangle. So this, as we know from previous lessons, this little square here, this signifies that this is a right triangle. So when we look at this triangle, the A and the B are always going to be the sides that are connected to this right triangle. We call these the legs. Okay, so when you're looking at the right triangle, the two sides that are connected to the right triangle, those are called the legs. Okay, and those are A and B. And it really doesn't matter which one is A, which one is B, that it just matters that they're both connected to this. The C is always going to be what we call the hypotenuse. Okay, that's just a big word to say it's the it's the side that is diagonal to your right triangle. Okay, so it's going to be the one that's opposite of your right triangle. So if your right triangle's here, your hypotenuse or your C would always be on this side. So if you had a triangle like this, okay, and this was your right triangle, we look, and the one that's on the opposite side or diagonal over here, this would be your C or your hypotenuse. Okay, and your legs would be on this side because they are attached to this center here. So whatever this angle is, this right angle right here, those legs would be A and B. Okay, so now that we know what those are, let's try to solve one of these. Okay, once again, do not judge my drawing because I am not an artist. But let's look at our triangle here. And we have our right triangle over here, our right angle right here. And let's go ahead and put in our numbers. So if I say that A is going to be equals 6 and B equals 8, and C equals unknown. That's what we're solving for. Let's go ahead and plug these numbers in. Now I know that my legs are here. My C is going to be over here, right? Because it's always diagonal of what, or the one that's on the opposite side. So I can put an A here and I can put a B here. And my C is going to be the unknown. Okay, so let's go ahead and use this formula here, and that is A squared plus B squared equals C squared. Now, when we plug these numbers in here, I'm just going to translate if this is my A and this is my B. Just going to translate these in here and I'm just going to plug my A in. So this is going to be 6 squared because my A equals 6. My B equals 8, so that's going to be plus 8 squared. And that's going to give me my C squared. Okay, so now when we do, change my pen color here, 6 squared, that is 36. And if you don't know how to do that, it's fine. Put that into the calculator, 6 squared, and that will give you the answer. But basically that is 6 times 6, okay? And then we do 8 squared, and that's going to give us 64. We add these two together, we come up with the C squared. And that's going to give us an answer of 100. Now, when we look at this triangle, would it make sense if we plugged in 100 here, that if we had one side that was 6, another side that was 8, and then another side that was 100? That doesn't really make sense to me, okay? So what happens is, see how this c squared is squared? We unsquared this one. We did the square root, which basically I'm calling it unsquared, but hopefully you know what that means. 6 times 6 equals 36. 8 times 8 is 64, but our c squared is not in the form of a square. It's in the form of a regular number. So basically what we get is an answer that is what we want is the square root of 100. Okay, our answer is going to come out and we need to put the square root of it. So if you put into your calculator the square root of 100, you would end up with 10. Okay, so our c is actually going to equal 10. Now that looks a little bit more in line with what our triangle says here. One side is 6, one side's 8, and it kind of makes sense that the other side is 10. Okay, so this is how you solve just the general a squared plus b squared equals c squared. But as you know from a prior videos, doing cost and time, or time rate, and then cost, when we did those videos, there's always a little change in how we do this formula. So let's work on that. Okay, so let's look at what happens when we're not missing the C value, but we're missing the A or B value. So in this one, we have the values to A and C, but we don't have the value to B. So once again, we're going to use the same formula, but we're going to change the way that we do the problem once we have the formula. So if my A is 8 and I don't have a value for B, and my C is 10, okay, we're going to write our problem as a squared plus b squared equals c squared, which is going to give me 8 squared. I don't have a value for my b, and my c squared is 10 squared. Now, I can't really do anything with this problem because I have my squares in here. I have my 8 to the second power. So what I need to do is I need to solve that first. Okay, so what I'm going to do is I'm just going to translate this problem into some numbers without these exponents in here. So my 8 squared is going to give me 64 because 8 times 8 is 64. I still don't know the value of this missing b, right? And then I have my 10 squared, which is 100. Now, you can see that these numbers are kind of similar to the last problem that we did, but we're doing the problem a different way because now I'm solving for the b, which is on this side of the equal sign, instead of solving for the answer, which is just a normal straight across problem where something plus something equals something. Now we have 64 plus something equals 100. So let's go ahead and do this as an algebra problem, which if you've watched the videos, you should be familiar with this. This is a positive 64. So to get rid of this on this side, because I'm trying to get my variable on this side by itself, as always, right? So I'm going to get rid of the 64 on that side. And what I do to this side, I must do to this side of the equal sign. That's one of the rules in algebra, right? So this is just going to simply cancel out. It's going to leave me with b to the second equals 36, okay? Now, what this is, though, is b to the second equals the square root of 36. And why that is because b to the second, it's the same thing with the c to the second. You really need to get that exponent off of that variable so that it can equal the square root of that. So basically, you're just putting the square root on here instead of on your variable. So we're going to do the square root of 36, and the square root of 36 is 6. Therefore, my missing side over here of b would be 6. Okay, so we just manipulated which side it is. I don't even want to say manipulated. We just changed the way that we did the formula here. Okay, so let's do another one here, and we're not even going to put the triangle in it, okay? I'm just going to give you the numbers, and I'm going to show you the last kind of caveat of this Pythagorean theorem that we're going to learn. So let's say that A equals 12, and let's say that we don't have a value of B, so that's an unknown, and our C value is going to be 16. So C equals 16. So let's go ahead and write out our problem of 12 squared because it's A squared plus B squared equals C squared. Okay, so this is the problem that we're looking at always when we are finding the area of a triangle. That does not change, so you might as well just memorize that. Okay, so if we're looking at this, let's go ahead and translate these numbers here, and let's just start solving this. Okay, and our C squared is 16 squared. Okay, I'm gonna have to use my calculator on this one, but excuse me, you get the concept. Our A is 12, and we're gonna do squared because the formula tells us to. Our B squared, we don't know, and our C squared here is 16 squared. Again, we have to use that exponent because our formula tells us to. So let's go ahead and look at what 12 squared is, and that is going to be 144. Let me use a different pen color here. So that's going to give us 144 plus B squared. Now, we still didn't solve for B squared because we don't know what it is. So we're still working this problem, okay? And then we have 16 squared for our C, and that's going to be 256. Now, we just talked about how we do our algebra, so we're just going to simply do this with our algebra, minus 144 from here to get our B by itself. And we're going to do the same thing to the other side. And this is going to give us B squared equals 112. Now, remember, you might as well put this here because we're trying to get this exponent onto here. We're trying to figure out what the square root of this is. Now, if you put this in your calculator as the square root of 112, it's going to give you a weird number. Like it might even come out and say, it'll say something like 4, 7, right? Or it might even say something like this, okay? What that means is that there is no exact number that when you times it times itself, it equals 112. So like if we have the square root of 100, 10 times 10 equals 100. There is no number, no whole number times itself that equals 112. So a way to fix that is you're going to get a number that is close to, or they sometimes call it about, okay? So your number is going to be about the square root, right? So we're going to try to get as close as we possibly can. So by doing that, if you hit your calculator, after you have this funky, I came up with this in my calculator. Okay, after you have that, you want to go down to the bottom right corner of your calculator and you have that little translation key down there. I like to call it a converter key. It's right above the enter button. And if you hit that button right there, it's right above the enter button on the right bottom. If you hit that little number right there, it's going to give you 10.583000524. Okay, so now when you hit that, it's going to convert it for you to the closest possible decimal digit that it can get to come close to this. And that's why they say it's about, right? It's about 10.58. And for this example in our workbook, this is asking us to round to the nearest hundredth. So our answer would be B equals 10.58. Okay, so it will give you an on or about number. So just remember, whenever you put something into the calculator for a square root, and say like it's 112 and you come up with something like this, hit this little converter key and it will give you the about number or the closest number that's possible. And that's what they're looking for. Because if you're doing a triangle and you have one side that's 12, one side that's 16, your third side is not going to be 112. That just doesn't seem to make sense when you're looking at a shape that should be kind of proportional in its size, right? But if you put in 10.58, that kind of fits somewhere in that game plan there for what that shape is. So this is all that has to do with the Pythagorean theorem. It's just a big name for this formula. You want to memorize your A squared plus B squared equals C squared. Because whether you're missing the A, B, or the C, you're going to use this same formula to solve any of these. You're just going to determine how you solve it by which one is missing. So I hope this makes sense. If you have any questions, let me know.